Okay, so we're starting with an easy warm up to the course. Hopefully, this will be easy, but really important. Um, we're going to do a lot of factoring and we're going to start doing it soon. It's going to kind of last throughout most of the course. So it's something that, isn't going to go away. And it's important not only that, we know how to do it, but that so we're proficient at it, meaning we can do it accurately, we can do it well, consistently, and then also that we're efficient. We can do it quickly. And the reason for that is we do so much factoring, we do bigger questions where factoring is a small part of it. And if you can't do it quickly, efficiently, then it's just going to take too long to finish all of the questions. So any little tricks that come up, any little uh, things that you can do to save some time, all of that is going to be great. It's going to be stuff that you're going to want to think about and um, just be aware of and try using it as you practice and see if you can use those tips and tricks or whatever they are. Okay. So this lesson is just about factoring some different kinds of polynomial expressions. One of the first things, and in fact, in this course, you will notice that I talk a lot about observation. So when we get started on a question, like I said, we do questions that are big questions. They take a long time to complete. And when you first approach the question, you're going to start to make some observations. So you're going to say, oh, it looks like this. Oh, it looks like this. Oh, it looks like this. I know this seems pretty cryptic right now because we haven't gotten into the course yet, but you'll see when we get there. And so I talk a lot about observation. What do you notice? What jumps out at you? Like what's happening? And that's gonna dictate how you approach the question. So in factoring, it's this is something we're going to be very good at, I think, because you've been factoring since grade 10. But what you notice, the first thing you're going to notice is what kind of factoring is it going to be. So we've got a few different kinds of factoring questions that we're going to look at here. And the first thing you have to determine is what kind of factoring is this? How can I factor it? Which of these uh, um, procedures does it fall under, right? Which one of these categories does it fall under? So that's the first thing that we're going to do. And that's what this quick summary is all about. So let's get into it. Um, we're going to look at the different kinds of factoring, how you can observe, how you can notice which type it is. And then when we do some actual examples, we'll show the actual strategies, the actual procedure of how to factor. Okay, so one thing, the first sort of thing that we should always be looking at is common factoring. Common factoring can have any number of terms. Okay, 2 terms, 3 terms, 4 terms, 10 terms, whatever. Always look first for a common factor. There's several reasons for this. Um, Generally speaking, in this course, we're not just going to give you a question like this and say factor. We will actually learn some new factoring strategies. And so for those few days, the question will say factor the following fully, which means you have to common factor if there is one. But generally, it's a skill that we're going to use to do other things. And so common factoring first is going to have a lot of benefits. Um, it's going to make the question easier. It's going to make you be able to do it more quickly, that kind of thing. And in some cases, there will be things that we can do that not only make the factoring easier, but make the whole question easier. So, there's lots of good reason to get in the habit of common factoring first. So always look for a common factor first and look for factors, common factor of numbers and variables. Okay, and we're going to see that in some of the examples that we do. In some cases, you may not have to, an expression might have a common factor and you don't even have to pull it out. It won't matter. So we're going to, again, something else in this course we're going to notice is there are less strict rules for what your answer necessarily has to look like, that kind of thing. But anyway, that'll make more sense when we get into that part of the course. Factor by grouping, we're going to look at this a little bit later, not really too much today. This is something that you do in grade 10, probably don't do much in grade 11, but there will be a few times in this course where it's going to come back and it's going to be useful to review factor by grouping. These are the ones that we really want to get into today. Simple trinomial and complex trinomial. And simple trinomial has 3 terms because it's a trinomial. And the key to it that makes it different from a complex trinomial is the coefficient of the x squared term is 1. Okay, that's what makes it a simple trinomial compared to a complex trinomial. Notice complex trinomial, 3 terms, but the x squared coefficient is not 1. Okay, so it's got some number in front of it. And the reason why you have to determine this, and again, this is going to be really easy once you get back in the habit of factoring. This is a no-brainer. It's not going to take you time to determine which one it is. You're not going to sit there thinking about it. You're going to just know. But it's a great, but this is, I really like, um, generally speaking, this factoring. If we step back and think about these little observations that we're making, and those observations tell us what we're going to do next, that's a really, really neat skill and really useful. And we're doing that more often than we're aware of. And so that's why I still like to kind of talk about it and point it out. So if you've got three terms, you might be looking at a simple trinomial, or you might be looking at a complex trinomial, and we'll see some examples of those coming up. And then the last couple, difference of squares is a big one. Generally, you've got two terms. They're both perfect squares. Hopefully we know what that means. Hopefully we know our list of perfect square numbers. And there's a minus sign between them, or you could rearrange it to put the minus sign between them if it's not actually between them on the page. We'll talk a bit about that as well. That's usually an easy one, usually a straightforward one. Last one, perfect square trinomial. You don't really need to know this one. There are a few procedures that we do in mathematics that require the use of a perfect square trinomial. Complete the square is the one that we start doing in grade 10, and that comes to mind. And you kind of need to know what a perfect square trinomial is for that. But otherwise, if you notice that it's a perfect square trinomial, it might make you able to solve the question a little bit faster. Again, efficiency is good. The other thing is there's something we're going to do pretty soon in this course, actually, where noticing that will help us organize our solution in a way that's more helpful. So, you might notice it, you might not. In the end, it probably won't matter too much. And I'm not going to go into a lot of detail about this one right now, but it is a trinomial, so it's got three terms. And then those three terms have to follow those two, which you can't even see, so I'll zoom out. Those two conditions of the pattern in the coefficients, that kind of thing. Okay, so when it becomes more relevant later on, we'll probably talk a bit more about this, but for now, we're not going to worry too much about it. All right, so let's dive into some examples here. So, as I said, first thing we're going to do is we're going to make some observations. What do we notice about this? Well, I notice it has three terms, so it's a trinomial. But it doesn't look anything like a simple trinomial or a complex trinomial. It's got all these m's and n's and all these kind of crazy exponents. And so, it's neither of those, and this is just a straightforward common factor question. So what I do for a common factor question, and we're never going to see another question like this after today. We don't really work with expressions. This is called a two variable expression, and we really work with single variable algebra and single variable expressions. So we're not going to see anything like this, but it is good to review. It gives us a good review of the basic rules of common factoring. I look at the coefficients first, 4, 8, and 10. I think, what number can I divide out of all of those? The biggest number is 2, so that's the one I'm going to take out. Always take out the biggest. Then I'm going to look at the m terms, and I'm looking at their exponents. And again, I want to take out the biggest that I can take out of all of them, which turns out to be the one with the smallest exponent. And so then in this case, that's a 1. So I can pull out, I don't want that bracket there, pull out m to the 1, and we don't write the 1. And then same thing for the n's. I've got a 4, a 2, and a 3. So I'm going to pull out the smallest. And that turns out again to be in the middle term there, which is n squared. So I'm going to pull that out. Okay. Now I divide. 4 divided by 2 is 2. M squared divided by m to the 1. So remember, you're subtracting exponents when you're dividing powers of the same base. So 2 minus 1 is 1, so it's m to the 1. N to the 4 divided by n squared is 4 minus 2, which is 2, so n squared. And again, the trick is, and this is always good to think about with factoring, it's something we're going to do when we start to learn new factoring rules, is the idea is if I re-expand, so if I multiply these two terms back together, if I were to, I'm not going to, but if I were to, I'd get back the original expression that I factored. Okay, so you can always do a check. Negative 8 divided by 2 is negative 4. M divided by m is 1, it's gone. N squared divided by n squared is 1, it's gone. So that one's done. 10 divided by 2 is 5. M cubed divided by m, 3 minus 1 is 2, so m squared. n cubed divided by n squared. 3 minus 2 is 1, so n. And I'm done. And you know, you might look again to see if there's another common factor there, but if you did it right the first time, there won't be, and you should be good. If there is, then you should go back and fix that and make sure you factor it fully, because that's going to be helpful. I would imagine people might ask, hey, what about that? Should I rewrite this and put that constant at the end? You know, again, this is something that we're going to talk a fair bit about in this course, because I like to talk about these things. I don't have any set rules for, I mean, in some cases there are definitely rules for how you have to write your answers, but for the order in which you write an expression, there's not really hard rules in mathematics. You have to write it this way. There are standards, the way we tend to do it, and that's in order to make our life easy. It means other people can read your work more easily. You're going to notice patterns more easily. So like there's a real good reason to do it. So that's how we're going to do it. But in this case, there's no reason to rewrite this and put the constant at the end. Like what use is that? We're not doing anything else with this expression. We're not doing any more steps. So I don't see the point. If we were going further with it, then that certainly is something you might do, is rearrange it to write it in the correct order. Okay, so that one's done, common factor. Next one. Well, hopefully we noticed this already. Hopefully this is familiar. We've definitely got 3 terms, and the x squared term, it wouldn't matter if this was written out of order, right? If it was written like this, negative 5x plus x squared minus 14, that doesn't mean I'm looking at that first coefficient. The order of the way an expression is written rarely matters. This actually comes back to what I was just saying about patterns. The reason why we write it in the same order is because it becomes easier for our brain to just look at the first one, because that's what we care about. But you would always be looking at the coefficient of the x squared term, whether it's written in the first position or the second. And in this case, it's a 1, so this is a simple trinomial. Okay, and this is the pattern for this one is you're going to have 2 brackets, and you're just going to have an x in front of both. X times x is x squared, right? So that's why that works. And now, if you remember, I'm looking for 2 numbers that multiply to the negative 14 and add to the negative 5. And because they're multiplying to a negative, one of them has to be positive and one of them has to be negative, because when you multiply a positive and a negative, you get a negative, right? So they have to have opposite signs, which means the difference between them will be 5. Okay, so I'm going to be subtracting them to get the 5. So not many things multiply to 14, so this is clearly 7 and 2. And now I have to figure out which one's positive, which one's negative. And I want the answer to be negative 5, so I need the 7 to be negative. Negative 7 plus 2 is negative 5, right? And that's what I mean by the difference has to be 5. 7 minus 2 is 5. And I know that they have to have different signs because the product was negative. Okay, again, observation. Like this is something we notice, and then that helps us figure out what those numbers are going to be, because we have to know that they're subtracting to 5 as opposed to adding to 5. All right, and again, you could check this by re-expanding. X times x is x squared. Negative 7 times positive 2 is negative 14. And then positive 2x minus 7x is negative 5x, right? So you can always check, and whenever you can check, we're going to talk a lot about this in the course. Whenever you can check, as long as you have time, if it's a test and you're running out of time, but as long as you have time, it's always a good idea to check your answer. All right, so next one, looks like we have a trinomial again. But this one's different because this one has a coefficient that's not 1 in front of the x squared term. So it looks like, oh, it might be a complex trinomial, but I bet people are already noticing that that too can be common factored out. So we're going to common factor first. And the reason why is that's going to make the next step way easier, because now in this case, this won't always happen, but in this case, now I got a simple trinomial, and simple trinomials are a lot easier to factor. This one's cool because when you have a 10 and a 24, there's a whole bunch of different combinations that might work. Whoops. So 6 and 4 multiply to 24 and add to 10, right? But 6 and 4 won't work in this case because it's the same thing. I've got a negative here, and that means they actually have to subtract to 10. So in this case, my numbers are going to be 12 and 2. And again, I want the 12 to be negative, and the 2 to be positive. So it's negative 12x plus 2x gives me the negative 10x. And negative 12 times positive 2 is negative 24. And x times x is x squared. Okay. Common factor first. Be careful, check your answers, double check, especially when there's some negatives in there. Even if we're good at this, sometimes if we're rushing too much, we can make silly mistakes and get the wrong answer. And again, a lot of what we're going to do is not just factoring. We're going to factor it and then we're going to do all kinds of other stuff. And if you factor wrong, you may not be able to do all the other stuff. And we have some questions in this course that are worth upwards of 20 marks, just one question. And if you make a mistake factoring in the beginning, you're going to lose a lot of those marks just because you can't do the rest of it. You can't show your work. So it is really important that although I'm saying to be efficient and to be able to do this quickly, we don't want to rush because we want to make sure that we're doing it accurately. Otherwise, it could cause some pretty major problems. Next one, trinomial again. And in this case, though, I've got another coefficient in front of the x squared. That's not 1, but definitely not common factoring out. So this is a complex trinomial. And I should have done D and E in a different order maybe, because I'm actually going to do a different kind of a trick to this one. And so if you need to go back and watch this again afterwards, then come back and watch this part of the video again afterwards. Might be a good idea. We have a particular way that we organize our solution to factor complex trinomials. But there are times where I can cheat. It's not really cheating, but like I can avoid that procedure and speed things up a little bit. And those times are when either this number or this number are prime. And in fact, in this case, both are prime, so that's even better. If one or the other is prime, I might be able to do this one more quickly. And you might not feel ready yet, but after you've practiced for a few days, you'll probably, a lot of you will probably be able to do this. So what do I mean by prime? I mean, it doesn't have only two things multiply, right? If you're doing two things multiply to 5, it has to be 5 and 1. So what I'm going to do is I'm going to put 5 and 1 right in there in the first spot. I know that's what it has to be, okay? And the other great thing about this is prime, so I know these have to be a 2 here and a 1 here, or a 1 here and a 2 here. And I'm going to do this in a different color. I wouldn't actually usually write this down. Okay, I'm just writing it for the benefit of this lesson. I usually do that in green when I'm doing lessons. So I know it's one or the other. And so in my head, I'm able to, and a lot of you are going to be able to do this, just kind of do it in your head because you only have two options. Which one of those two things can I make add to 9? And again, in this case, it's negative, so they're going to have opposite signs. So it looks to me like it's going to have to be a 2 here and a 1 here. And the reason is I get 10x when I multiply those, and I get 1x when I multiply that. And so 10 minus 1 is 9. So that's how I know that I have them in the right spot. And if I do this check, if I have them in the wrong spot and I do this check, I'm going to figure that out, right? And I just use a pencil, erase, fix it. Now, I still have to do the signs. Do I want it to be 1 minus 10 or 10 minus 1? I want it to be 10 minus 1 because it's positive 9. So that means the 10 is positive. So 5 times positive 2 is positive 10. And negative 1 times x gives me the negative x, and 10 minus x is going to give me the positive 9x, right? So again, always check, because even I sometimes get the signs in the wrong spot, but I'm pretty used to checking my answer to make sure. And a quick check, positive 10x minus x is positive 9x is always a good idea. Okay, so in that case, I kind of cheated a bit, and I didn't actually write out the little system that we usually do for complex trinomial factoring. And like I said, because that's the first one we did, that may have gone too fast for you. Come back and watch it again. If you don't like it, if you can't do it that way, you don't have to do it that way for sure. In terms of these kinds of factoring questions, we don't actually expect you to show any work. You don't have to, so you could do it however you want. So if you do it this way, great. If you do it a different way, that's okay too. Let's move on to the next one. Again, this one, trinomial coefficient in the front there, and although I can factor something out, there is a common factor of 12 and 6. That's not going to work for 17. 17 is prime. So this is a complex trinomial factor, no common factor. So let's get started. And for this one, now I know it's going to look like this. For this one, I'm going to do the whole procedure. That's why I said maybe these are out of order. But I'm going to do the whole procedure, and hopefully you remember that. Now, if you didn't take grade 10 or grade 11 at our school, you may not have learned this strategy. There are other strategies, other techniques, other procedures for factoring complex trinomials. I don't care which one you use. I think this one is the most efficient. It seems strange at first, and some people avoid trying to use it because it seems too hard. But I think if it's too hard, then I think this whole course is going to be too hard. It seems hard at first, but with some practice, everybody I've ever seen gets there and figures it out, and it's a very efficient procedure for doing it. It doesn't require any extra work, no extra steps. It's all done in one step. You do write something off to the side, but once you start doing it, it also allows you to get familiar enough to start doing things like the cheating that I did over there. So there's a lot of reasons to do it this way. If you've never seen this before, go back and try to review your way. Ask me next time you see me, or send me an email and say, I couldn't follow that complex trinomial. Can you show me another way, or can you go over it more slowly, and I'll show you again. But for most of you, or maybe even all of you, this will be familiar, and this is, I think, the best way to do it. So what do we do? Well, I take this number, the coefficient of the x squared, and this number, the constant, and I write out the pairs of numbers that multiply to those two numbers. Okay, and I'm doing it off to the side. I always do this kind of work in a different color. So I do it off to the side. So I'm going to do it in order: 1 and 12, 2 and 6, and 3 and 4. Those are all the pairs of numbers, and you have to write it like this. You can't write it like this. Okay, 2 and 6. Don't write it sideways. Right? You have to write it the exact same way. Then you draw a line, and the x squared, the coefficient of the x squared, has to be on the left, and the constant has to be on the right. Okay, those things all cannot be changed. Then I'm going to do the 6 on the other side of the line: 1 and 6 and 2 and 3. And then I have to flip one side or the other, and I flip all of them. And I'm going to flip the right side because there are fewer pairs. That's the only reason why I'm picking the right side. And notice that I just flipped them both, and now I have all the possibilities, and I'm going to go through them to find my answer. Okay. All right. So that's the first step of writing this whole thing out. It doesn't take too long, right? Do it off to the side. You don't have to do it. I don't have to see it. Nothing like that. Okay. How does this work? I'm going to do one quick refresher. You can go back and rewatch the video if you need to see it again and again, or if you're not getting it, again, ask. Okay. What I do is, and this is easier to teach in person. It's a lot harder to do on the computer because you can't actually see me. But here's what we do. I look at this pair and this pair. So I always start with the first of each. Okay. And what I do is I multiply crosswise. So 1 times 6 is 6. 12 times 1 is 12. And in this case, because it's a positive 6, they're going to have the same sign. And so they're going to add to 17. So then I ask, does 12 and 6 add to 17? No, it's 18. It's close, but that doesn't matter. So So it's not those two. So then I'm going to flip from this, from the 1 and the 6 to the 2 and the 3, and I'm just going to go through every one at a time. And if none of them work, then I'm going to cancel that one, and I'm going to move on to this one, and then do every one of these again and go through them one at a time. And when you start to get good at this, you can start to skip some of these steps, and you're gonna just know it's not that's not those two, so I'm not even going to bother multiplying them. You're going to have a good guess of what it might be. Even this one, actually, I should say, before I move on, I'm looking at this and I'm thinking, I bet this one is 3 and 4, and I bet this one is 3 and 2. And it might be 1 and 6, but I bet it's 3 and 2 and 3 and 4. And so you could put 3 and 4 in there and look at it and say, can I get a 2 and a 3 in those spots, and do it in your head. And this comes with practice. You get better at it as you practice, and some of us are going to be better at it than others. Some of you might not like doing it this way. But you know, you do get good at kind of guessing at what it probably is, and you don't have to try every single one, and you may not even have to write them out like this. And again, that really helps speed things up. So I'll do this one. 1 times 3 is 3. 12 times 2 is 24. Well, again, that's not going to add to 17. So why am I even bothering, right? Like, why waste my time thinking about that one? So I'm just going to go ahead, and I don't usually actually circle these. You know, you might use your fingers when you're just practicing, but I just kind of look, and I kind of decide, well, it's probably 3 and 4. And turns out I think it's going to be here, because 3 times 3 is 9, and 4 times 2 is 8, and 8 plus 9 is 17, right? So that's going to be our answer. Now we read our answer across. So my first bracket is going to be 3x and 2. And my second is going to be across on the bottom there, 4x and 3. I'm going to kind of get rid of some of that stuff. Whoops, I didn't want to get rid of that. Okay, that's better. Now, okay, so I've got all that done. I think I've got the right pairs. Now I have to put my signs in. I know they're the same sign because they multiply to a positive, and so they're both negative because they add to a negative. And now I'm going to do a check. And as I said, if you can check, it's always a really good idea to check. So 3x times 4x sure is 12x squared. Negative 2 times negative 3 sure is positive 6. And this is the bigger one, negative 9x and negative 8x. Add them together, negative 17x. Okay, so I got it. And that's that procedure. If you've never seen it before, it seems a bit wonky. The answer seems to come out of nowhere. It seems magic. You don't really understand why you're doing it, but trust me, it is the most efficient way of doing it. And with some practice, I've never met anybody who can't get there. So, you know, if you haven't seen it, I would strongly suggest reviewing this a few times and seeing if you can do it, trying it. The weird thing is you don't understand it, so you don't even really know where to start, and you don't know what to do to try. And so it feels, for a lot of people, it feels strange, but you just have to. You have to force yourself to try to write out the pairs of numbers and try to follow the steps. And if you need a refresher, ask me. But you can use whatever you want. You can use whatever method you want. But you know, when you have to factor 3, 4, 5 times in one question, if you're using a slow method, it's going to be really hard to keep up. So just keep that in mind. That's why I like that method, because it's the fastest. And it gets us thinking in the right way to be even faster, like I did that one. Okay, let's get the last few done. It looks like another complex trinomial, doesn't it? But wait a minute. What do you notice? What do you observe? Yeah, there's a common factor of the coefficients, and they're all even, so I can definitely factor out 2. But I'm like, I wonder if I could factor out 1 or 4 as well. Maybe I could factor out 4. And turns out you can. So this is 3x squared plus x minus 14. So if you're not sure, most of us probably don't know that 4 times 14 is 56. So do it on your calculator or do it in your head. And sure enough, it does factor. And I still have a common factor, or a complex trinomial factor. Like, you know, it didn't turn it into a simple. Obviously, it won't always. But look at those numbers. Now I got a prime out in front. It's way easier. So I know this is going to be 3x, and I know this is going to be x. Okay, and you can write out the pairs of numbers on the side, and if you want to pause the video and try to finish this one, that's fine. Go ahead and do that. It's a good idea. But I know that it's going to be 3x and 4x. And again, I'm going to guess that it's going to be 7 and 2, because I don't think it's going to be 14 and 1, because I don't really see how I'm ever going to get that to add up to 1 in the middle. I'm pretty sure it's going to be 7 and 2. And I'm pretty sure the 7's not going to go there, because that's going to be 21. And again, that's just not going to work. So the 7 has to go there, and the 1 has to go there. Or sorry, 2. That wouldn't work if there's a 1. And so let's see if I can make that work. Well, this is 6x, and this is 7x. And sure enough, 7 minus 6 is 1. And I want it to be positive 1, so I want it to be a positive 7 and a negative 6. Okay, and then I'm going to get rid of that, and there you have it. 7x minus 6x is positive 1. 7 times negative 2 is negative 14. 3 times 1 is 3, right? Fantastic. Okay, so that's the trinomial factoring. Couple more quick ones left. This is not a trinomial, so we're not doing a simple or complex. What do I see? I see 2 terms. I see all perfect squares. 9's a perfect square, 1's a perfect square, a squared is a perfect square, and I see a minus sign between them. So this is a classic difference of squares. How do we do it? Square root of the first plus the square root of the second, square root of the first minus square root of the second. Square root of 9 is 3, square root of a squared is a, square root of 1 is 1. I bet everybody remembers that. A lot of people, that's their favorite because it's so quick and easy. What about this one? Okay, this is our last one for today. Sure looks like a difference of squares, but 8's not a perfect square and 50's not a perfect square. It does have a minus sign between them, but it doesn't matter if they're not perfect squares. But I know people have already noticed there is a common factor. I can pull out a 2, and now look at that. They are perfect squares. 4 and 25 are perfect squares. So now I can factor this as a difference of squares, and I'm done. Okay, so like I said, sometimes you have to see the common factor, otherwise the question won't work. Last thing I'm going to do, I'm going to talk about a couple more things. Whoops, almost about or wrong. So there is another way we could do this. It's very minor. Okay, what if instead of factoring out a 2, I factored out a negative 2? Well, then I would have ended up with 25m squared minus 4. And so notice how the 4 became negative and the negative 25 became positive. And so they just kind of traded places. And that only happened because I took the negative out front. Why would you do that? Do you have to do this? No, definitely don't have to. Why would you do this? Well, you're going to see later in the course, there are times where you might want to do this. It might make future steps in the question easier. This is a more normal way of seeing things with the variable in the front position and the constant at the end. So maybe it's even just more familiar. And this is just a good trick. There's no rule that you have to, but this is something that you should be able to follow and you should understand and start to think about when this might be useful. And in this case, now I can go ahead and factor it. And it looks almost the same because 5m plus 2 and 2 plus 5m are actually the same thing, right? Order doesn't matter. But 5m minus 2 and 2 minus 5m are not the same thing. But because of the negative out front, the entire expressions are equal. They're the same. Both of these answers are totally fine. There's no one that's better than the other. There may be situations where you want to have one instead of the other, but for a question like this, they're both totally fine, okay? So that's factoring in a nutshell. Like I said, we're going to do a lot of factoring in this course, so being very good at it is going to be important. And there's a lot of practice. Do as much of it as you need in order to get caught up, in order to get warmed up before we actually start the course. And, you know, every little bit's going to help. Trust me, you're going to want to be good at factoring once we get there. Like I said, there's going to be a lot of it. All right, that's it. Good luck.